this video, we're going to take a look at solving for the volume of this cone. And we're given this cone, what we're given is the cone, so we have this diameter here of the circle, which I'm just going to make sure we understand. This diameter is given as 20, so then that means the radius is 10 because the radius is half of the diameter, so the radius is 10. So from like here to here is the radius. And then we're given this information right here. That is the height of the cone. Don't confuse that with the slant height. The slant height is this. That's used for surface area of the cone, but we're looking for volume of the cone here, so we need to know the height of the cone. Now the formula for the cone. The formula for volume of a cone. It's kind of easy to remember once you understand where it comes from, because if you have a cylinder, so let me just create a, that's bad. If I create a cylinder out of this, what happens with the volume of a cone is all you're doing is you're taking the volume of the cylinder. So if I know the volume of a cylinder is pi r squared times the height, and the reason the volume of a cylinder is pi r squared times the height, because I'm taking the area of this bottom circle. This is the way I always explain it, of just why the volume of a cylinder is what it is. Because I'm taking the area of the circle at the bottom, that if I have a cylinder, the area of the circle at the bottom, and then I just multiply by the height. So then what happens then is it just, where's my highlighter? Here it is. You're getting all of this space in here then, because you have the area of the circle base, and then you multiply by, well, how much does that take up in terms of like its actual height? And that would be that. So then that would be the volume of the cylinder, so pi r squared times height. Now we're not talking about a cylinder though, we're talking about a cone. Oh wait, no, I don't want to do that. I'm going to keep that picture. So if you look inside the cylinder here, you see the cone, the original cone here. I didn't mean to do that. The original cone right here. All you do to the volume of a cylinder to find the volume of the cone is divide by 3. What that translates to is that you could fit those 3 cones inside. And you can kind of see that from this picture though. You got to kind of imagine though in a 3D dimensional space that you could fit these 3 cones to make up the entire cylinder. So if we divide by 3, we get the volume of the cone excuse me, on the inside. So that's all we need to do. So volume is pi times, let me actually rewrite this because that's kind of confusing. So that was the volume of the cylinder is this one. And then like I said though, the volume of a cone would be the same formula, pi r squared times height, but divide by 3. So in our scenario, we have pi times the radius, which is 10. I already talked about that. So 10 squared times the height of the cone, which is 25. Same height of the cylinder. So then we just do 10 squared is 100. So 100 times 25 is going to be 2500. And they want us to leave in terms of pi right here, leave in terms of pi. So that means we're not actually multiplying by pi. So you just write this as 2500 pi. And there it is, 2500 pi. If they wanted us to convert, we just do 2500 times pi, like an exact answer, or approximation, excuse me. Exact answer would be 2500 pi. But approximation would be 2500 times pi, and then you get the approximation. But that's just it. But I really like this video to talk about where the actual formula for the volume of the cone comes from. It's just taking a cylinder and dividing by 3. And so if you don't understand the volume of the cylinder, you understand the volume of the cone then. So you can fit that cone within there, and that's how we get that formula. So 2500 pi.